So we are now on the second page of this chapter 10 test, and it says neatly graph the system of inequalities. Your graph should clearly and accurately show the solution region. That's the shaded region of points that satisfy the system. In other words, makes both inequalities true at the same time. So this first inequality is y's are those things that are greater than or equal to 3x plus 1. That's fairly straightforward to graph, right? We've got a y-intercept there that's easily identifiable as 1. And we have a slope that's equal to 3. So from here I could go up 1, 2, 3, and then over 1. In fact, I might want to go down 1, 2, 3, and backwards 1. So that's also a positive slope of 3. Let me do that again, 1, 2, 3, and over 1. So I think I've got a pretty good idea what this curve's doing. And I also see that this is greater than or equal to the curve. So I'm going to go ahead and draw this as a solid boundary line because it contains them. And just as a quick test, right, if I put in 0, 0, I'm testing below the line. And you can see when I put this in, it says, hey, 0 is greater than or equal to 1. That's clearly false. So this is not the side that we should shade here. We should be shading those values that are above this curve. So we're going to shade everything above it this direction, not the stuff below that line. The other one says it's not. Yeah, actually, we could graph that using intercepts, x-intercepts, and y-intercepts. That would be pretty nice too. But I'm just going to go ahead and transform that into slope-intercept form. So I'm going to do that by subtracting 3x from each side. So this becomes 6y is less than negative 3x minus 12. You can see I subtracted 3x from each of the sides of the inequality. And now I'm going to divide both sides by 6. And negative 3 over 6x minus 12 over 6. And of course I could simplify that, right? Y's are those things that are less than negative 1 half x and then minus the number 2. So here I can see my y-intercept is at negative 2 and my slope is down 1 over 2, down 1 over 2. And I could also go up 1 and back 2, up 1 and back 2. So got a pretty good idea what's happening here, right? This is going to be a dashed line because you can see it doesn't say or equal to. So it's not on this line. This is just the boundary line. It's defining where the side, some things work on one side and they don't work on the other. And again, for this one, let me test 0, 0 again. When I put that in, this says that 0 is, 0, oh, let me get this right here. 0 is less than